If you dive into the freezing waters off Antarctica, you're going to notice something immediately wrong with everything around you. The spiders aren't tiny anymore. Jellyfish aren't floating by with delicate tentacles. They're drifting past with arms longer than a blue whale. Even the squids down here aren't just large, they're over 1,000 pounds of pure muscle and hooks. And this isn't some freak accident of nature. This is polar gigantism, and it's turning everything in these frozen waters into something they were never supposed to be. You'd think that in an environment this brutal, where the water's barely above freezing and food is practically non-existent. Smaller bodies, less food needed, better survival odds. That's how it works everywhere else. But Antarctica decided to throw that logic completely out the window. Instead of getting smaller, creatures here exploded in size. Small things became big things became massive, and massive things became something that sounds more like a myth than reality. So what's actually causing this? Because if you think it's just about having more space or less predators, you're missing the real reason. It all starts with something you probably didn't think mattered that much: oxygen. Cold water holds oxygen differently than warm water does. In tropical oceans, the water's warm and oxygen levels are relatively low. For most animals, that puts a hard cap on how big they can grow, because larger bodies need exponentially more oxygen to keep their cells alive. But in Antarctic waters, where temperatures hover around 0 degrees Celsius, the water becomes absolutely saturated with oxygen. There's no cap anymore. The limiter is gone. Once that limiter disappears, evolution starts pushing animals bigger and bigger. Because if oxygen isn't the problem, then having a larger body suddenly becomes an advantage. Bigger bodies store more energy, conserve heat better, and can survive longer without food. Take the colossal squid. Most people think it's a case of deep-sea gigantism, but they're wrong. The colossal squid is almost exclusively found in the Antarctic Ocean, swimming through water that's at or below freezing. And yes, it's a member of the glass squid family, which are normally translucent and delicate. But there's nothing delicate about a colossal squid. These things are over 1,000 pounds, with eyes the size of dinner plates and rotating hooks designed to tear through flesh. They didn't just grow bigger, they completely abandoned their glass-like appearance and evolved into something built for cold water dominance. Their reddish skin absorbs light instead of reflecting it, which makes them invisible to bioluminescent prey. And when you're this massive, you don't really need to worry about predators, except for the occasional sperm whale. Your entire body becomes designed for ambush, not escape. But the colossal squid isn't even the most extreme example. It's just the most famous one. Because if you look at sea spiders in a tropical reef, you'll see something small and harmless, about the size of a house spider, maybe an inch or two across. But find that exact same species in Antarctic waters, and it's suddenly over 2 feet wide. Same family, same genus, completely different size. And the reason is identical to why colossal squids got so big: cold water, high oxygen, and evolutionary pressure to grow. These sea spiders don't just look terrifying, they hunt like it too. They creep across the seafloor on those absurdly long legs, using them like stilts to step over sponges and corals. Then they extend their proboscis, pierce into something like a starfish, and suck out its insides like a milkshake. And yes, the starfish they're hunting are also gigantic. Some Antarctic starfish have over 50 arms instead of the normal 5. They didn't just grow larger, evolution started stacking on limbs like it was trying to see how far it could push things before something broke. And these starfish aren't passive filter feeders either. They're brutal predators that will eat other starfish whole. Whoever has the most arms wins, apparently. They also live for over 40 years on average, compared to the 5-year lifespan of their warm water relatives. Everything here is slower, bigger, and built to last. But the most extreme example of polar gigantism isn't even a predator. It's the lion's mane jellyfish, the longest animal on Earth. Compare its length to a blue whale, and you'll see the lion's mane is noticeably longer. Not heavier, obviously, but longer. And if you compare it to a blue jellyfish, which lives in warm water and belongs to the same genus, the difference is staggering. The blue jellyfish is delicate and small. The lion's mane is a drifting nightmare with tentacles that can stretch over 100 feet. So how does oxygen alone allow things to spiral this far out of control? Because it's not just the oxygen. The cold also slows metabolism down to a crawl. Large bodies become more efficient because they burn less energy per unit of mass. And the Antarctic environment is absurdly stable. The temperature barely changes, the pressure is constant, and predators are rare. There's nothing forcing animals to stay small and fast. They can afford to be massive, slow, and built like tanks. But here's where things get interesting. Polar gigantism only works on cold-blooded animals. Creatures that get their oxygen directly from the water and let the environment control their body temperature. For them, colder water means more oxygen, slower metabolism, and zero energy wasted on generating heat. But warm-blooded animals like polar bears and penguins can't take advantage of this. They have to burn energy constantly just to stay warm, no matter how cold it gets. The bigger they are, the more calories they need, and in the polar regions, food is scarce. So why are polar bears still bigger than other bears? That's Bergmann's rule, which says warm-blooded animals in colder climates get bigger because larger bodies lose heat slower. It's about insulation, not oxygen. But there's a hard limit. Getting too big becomes a massive liability because you need exponentially more food. Polar gigantism doesn't have that limit. It just keeps pushing until something else breaks the system. And on a smaller scale, even plankton have their colossal versions. Antarctic copepods are nearly 10 times heavier than tropical copepods. Most copepods are so small you need a microscope to see them. Antarctic copepods can reach up to a centimeter long, big enough to see with the naked eye. In the world of plankton, these things are absolute behemoths. But not everything in Antarctic waters got bigger. A few species went the opposite direction and developed polar dwarfism. Certain ice fish and snailfish are noticeably smaller than their warm water relatives. When food is only available for a few months out of the year, staying small means you can reproduce faster and survive longer periods of scarcity. It's not as impressive as turning into a sea monster, but it's still a viable survival strategy. And here's the weirdest part. The cold doesn't just change what evolves, it changes how fast evolution itself happens. In Antarctic waters, everything runs in slow motion. Metabolism slows, reproduction slows, and a single generation can take decades to complete. This makes evolution crawl forward at a glacial pace. Many of these species are living fossils, almost identical to ancestors that swam here tens of millions of years ago. Some sea spider and urchin lineages have barely changed since before humans existed. The environment has stayed stable for so long that evolution never needed to speed up. Every creature here is fine-tuned for a world that's cold, predictable, and unchanging. And that's worked flawlessly for millions of years. But that stability is exactly what makes Antarctica so fragile. Because polar giants have one massive weakness. They're all built for stability, not change. Their entire existence depends on water that stays freezing, dense, and packed with oxygen. Take that away, and the whole system collapses. Warmer water holds less oxygen, metabolism speeds up, and suddenly those massive bodies become a death sentence. The animals that once ruled the frozen deep start suffocating in their own size. This is already happening. As oceans warm, oxygen levels are dropping fast, and creatures that evolved for the cold are running out of room to survive. Studies show that maximum sea spider sizes are shrinking in areas where water temperatures are rising. Colossal squids could eventually become uncolossal, or just disappear altogether. And while I'd never want to encounter a 1,000-pound squid with rotating hooks face to face, it's kind of tragic. These creatures are living relics from a different world, and they're zero threat to us anyway. Total human deaths from colossal squids? Zero. No one's ever been attacked by one. But the effect that cold has on evolution is one of the strangest and most unexpected forces on the planet. Freeze the ocean and life doesn't die. It just gets giant. Thanks for watching.